Hey, .NET developers, did you know you can use your developer skills to build microcontroller devices? The .NET Nano Framework is here to help you do that. And Laurent is joining us on the IoT Show today to show us how that works. Today on the IoT Show. Hi, everyone. This is the IoT Show. I'm Olivier, and today I have Laurent to discuss .NET Nano Framework. Hey, Laurent, how are you?
Hey, Olivier, all good, and you?
I'm fantastic. So I'm a French guy in Seattle, or actually in the east side of Seattle. You're a French guy, but where are you calling us from?
Well, I'm currently in Moscow, but I'm technically based out of Paris. So just like I like to be, somewhere on the planet. It doesn't matter
Nice.
really the size, right?
I like that. And what are you doing at Microsoft? What is your role?
Well, I'm a principal software engineering manager, and I'm working with customers to really help them move into Azure mainly, and around all IoT things. So yeah, I like those kind of things.
Nice. And I hear, because that's what you're going to demo today, that you also like IoT for yourself, like kind of home projects, using it
Yeah.
for enhancing your experience at home, right?
Yeah, absolutely. So I'm a big fan of IoT for years, even before it was called IoT. And I'm one of the main contributors for .NET IoT and as well .NET nanoFramework. And you may ask me, what's .NET nanoFramework, right?
That's the question was in the title. So we definitely want to tell people what that .NET Framework is about.
Yeah, well, .NET nanoFramework, it's a community-led .NET implementation that works on MCUs. MCUs, those are small processors, like very small, like the ESP32, for example, or STM32, and it's fully open source. It's coming from .NET microframework. It's a fork of
Okay.
.NET microframework. Yeah, and it's evolution. It has like kept like all what was great and really enhance it. And you can find it, online on GitHub. It has a lot of repositories. Things are split into a small part. It's part of the .NET Foundation, so it's really part of the .NET family, recognized like that. It's a fully open source project. Well, we are looking for sponsors, so if anyone is interested, like please don't hesitate sponsor us. And you can see here a couple of boards that are supported fully by nanoFramework. So all the ESP32 ones, you have some ST Electronics ones, Texas Instrument, and XP, and those are the official ones. There is as well like community target repository where you have much more supported boards. What's supported is mainly GPIO, SPI, I2C, PWM, like, all what you can find on those processors. And of course, the networking stack, which will interest us today.
Of course. So tell me, Laurent, I'm curious about a couple of things. We're talking about microcontrollers, so limited resources.
Yeah.
And usually .NET is kind of a big framework. It is designed more for servers and PCs and this kind of machine, sometimes mobile devices, but mobile devices now are PCs or are, pretty powerful. So how does it work in terms of compiling, interpreting like CLR? Like, can you give me the gist of it? Not the details, but at least the gist of it so that embedded developers realize what that means. And also that .NET developers realize that they're going to build things in a language they are familiar with, but it's going to be running on microcontrollers in an optimized way.
Exactly. Yes, correct. So, of course, it's not a full framework. It's called nanoFramework because you take just the very core part of the framework, you just get rid of all the rest, and then you have nanoFramework. Okay. So if you're trying to look for generic async, it's not there in the framework. Generics are coming, but not async. If you are looking for things which are very complicated, it's not there. It's really like, imagine like the very simple part of .NET, what is very powerful, still very advanced. I mean, all the compiling tools that we are using is the same chain. Then after, there is a big wipe happening so that you can get like the very small code. Technically speaking, on the MCU, what you have is that you have a native C code that you really don't see when you're a developer. You just flash your device, and then you have, the ability to deploy .NET. What I can do maybe is I can do a demo for you. Like I will
I was
show
about to
you.
ask for it.
Yeah,
Yeah.
I will show you how to do like an Hello Nano world and something like that. So if
Okay.
I switch to my Visual Studio, what you'll see here is normal Visual Studio, normal .NET code. Like, I mean, you're using your system. You have debug lines, you have functions. You even can use like the C#9 style. Okay.
Mm-hmm.
So it's really like, .NET, you're at home, right? What you can see here is like I have a device connected. It's on ESP32. Okay.
Okay.
The project solution is just like a normal project solution. You have reference properties, you have package, you have configs, you have all what you need. And now what I will do?
Let me ask you, the device is connected over serial over USB, right? Like you
Yeah,
do on
absolutely.
usual development. Yeah. Okay.
Yes, absolutely. It's usual development. You connect the device, like they are connected. It's a small cable, so I won't be able to show you, but it's there. And what I will do is that just press F5, right? Like I do in a normal development. I press F5. You see, I've put a breakpoint here. So what it's going to do now is that it's going to find the device. You'll see that on the window below. So it's compiling. It will find the device if it goes right. Yep. And then it starts to erase the device, deploy on the device. So it's deploying now.
While it's doing that, all the support for each of these boards is part of the package, right? So the fact that it's
Absolutely.
able to flash and so on is something that is part of the open source framework.
Yeah, absolutely. Yes. So you have an extension to install in Visual Studio. That's the nanoFramework extension. Very easy to find. Once you have that, you just have to flash your device. It's one command line, and then you're good to go. See, I put my breakpoint. It stopped.
Nice.
It's trying to do the same 30 plus 12. My sum here, I've put it in a watch. It's 0 so far. I can do step by step. I can do dive inside, and here I can see the value. So I can even change it. I can do in the real framework. So we all know that's not going to be the right answer, right? But if I want to change it, I can do it like, for example, like 43. It will change. So you see the value has changed here. And as a result, I should see in my debug here window, something like 43. Okay. So 43. So I can see my 43 coming here. Okay.
Nice.
Which obviously is not the right answer, but I've changed it.
Yeah.
Okay. So
nice. Okay.
I can really go like that for any .NET code, and all what you write is working like that.
Okay, so familiar for people who are developing with C# and .NET, yet it's on devices. And you have a project that you were telling me about that you applied nanoFramework onto. So tell me a bit more about that so that we can talk about the device access, connectivity to the cloud and things like that.
Yeah, sure. So my project is it's the usual one. It's about connecting a few sensors in my garden on a solar panel with battery, and this is the prototype that I have in this room on my bag. So you have a solar panel, a battery, you have the charger, you have here an ESP32 and a sensor. It's a BMP 280. I'll go explain you in a few seconds. In terms of electronics, that's very simple. I mean, it's just connecting cables here, just like a condensator, because the battery is not that powerful. It's an old one from an old phone. I just need to buy a new one. And that's basically it. So in terms of connection, it's very straightforward. Just read the manual. You connect, all the cables in the proper place, and that's it. In terms of code, that's part of the sample we have in nanoFramework, and I will show you a few things here. The first one is that we have Nugget packages. Okay, and some of those Nugget packages are called like Azure devices, etc. Sounds very familiar, right? It's like for the Azure SDK, and that's normal because we have an Azure SDK for nanoFramework. It's not the full one; it's a small one, very close to the full SDK. well documented, and that will allow me to connect. The second thing is that I say I have a BMP280. That's a sensor, and we have as well a wide collection of sensors available through Nuggets, and one of them is the BMP family, the BMXXX family, which I can add in my project. So when I have that,
so as we were saying earlier on, so once again, the same way the boards or BSPs or support packages are part of the .NET Nano framework GitHub repo. Same things for the devices here, right? So the way you access devices is provided by the framework.
Yeah, absolutely. And as you can see, like it's like really like Nugget packages. They are all starting with nanoFramework. So you start nanoFramework. You just had what you have. You see, we have JSON. We have things which can be specific to a specific hardware, and that's about it. And just add them, and then you have all the magic of .NET here. So like those 5 lines here, that's just to connect to the to the sensor, measure the sensor. Here for the we have helpers to connect, for example, to Wi-Fi. We have, of course, in the SDK, the capacity to connect to Azure IoT. You can upload your certificate on the device, so you don't have it to have it in your code. That's a possibility, or you can have it in your code. You can get your twins like very easily, and the Azure IoT twins, like, hey, get my twins. You can check if you have a property. You can get your property if it does exist. You can report your properties, and you see it's like 1 or 2 lines every time, and it's just like traditional .NET code. And if you are familiar with the normal Azure SDK, it's very, very close. You can almost reuse what you've been doing. Okay, and of course,
about reusing, actually, Laurent, I had a question when I was seeing you navigating through NuGet packages. Because it's .NET, are there limitations in terms of which libraries you can use? Your common libraries as a .NET developer. I want to parse JSON, for example. I want to do these kind of things. What do I need to pay attention to as a .NET developer when developing for Nano Framework?
Yeah, well, it's a small MS core lib, so it's not the full one. It's a specific MS core lib, and you find it as well as a package on Nuggets. Okay. And once you have it installed, then you have to use the feature from MS core lib. So if you're writing some code that you want to reuse, you have to take care of a few things. Like generics are not supported yet on nanoFramework. It's coming, but clearly no async, for example. So if you want to reuse code, then better have like simple code with no async. Limit the number of threads. There is multi-thread on Nano, but it won't work, with thousands of threads. Things like that. But all the devices we have from the one I've shown you from .NET IoT, we've migrated them for nanoFramework. Not all of them, but a large part. And it was quite straightforward with a couple of changes and things like that. So
nice. Talking about the
use a lot.
Nice. Talking about the devices, libraries. So for .NET developers, or people who are not familiar with embedded development, there are concepts or field buses like I2C and others that, or not field buses, but local buses that might not be super easy to understand. And very often when you're doing C development, you have to know, hey, that specific device is sending me that piece of information on that bit, and I need to do that, and blah, blah, blah. How do you present that? Can you show us a little bit of piece of code that accesses some of the hardware resources here?
Oh, yes. So for example, if I go back to this repository, and if I go back to the BM family, I can show you, really what's been implemented. So you have like all that implemented. So if I take the BMP 280 here, then you have like low-level code here. Of course, like we are iterating for the 280 base, so I have to go to the 280 base, which is in front of me here. And here you should have like a lot of low-level elements there. So you have like all those bit stuff, you read register, you cast a couple of bytes, you make all this magic. And that's totally hidden for you. You've seen, like I just did like few lines of code. I just do high-level coding, and I don't need to care about all of that. So if I go, deeper, there is like quite some code which is already there to really help you, and you don't really have to care about that. And if you want to calculate the compensate pressure, those are complicated stuff, and it's done fully transparently for you. What we are using as well, we are using something which is very convenient when you're working internationally, is that we are using a UnitsNet. So we have nanoFramework UnitsNet support. And the idea is that you don't really have to care about the units, right? Because in the US, they're counting with this strange stuff called Fahrenheit. The rest of the world is counting with Celsius, for example, the temperature.
About it.
And and I never managed to convert. And all our bindings are using this concept of having a pressure, of having a temperature, and you don't have to care about how to measure that. That's done for you. So that's the magic as well that we are bringing with .NET, with .NET IoT, and on .NET nanoFramework.
Okay, Laurent. So I want to see it in action. You were talking about the Azure IoT SDK, so you can connect that to the cloud. So not only can you interact with the hardware, gather the data from the sensors on that little device, and then send it to the cloud. There's a very interesting thing. You talked about solar panel, and we'll talk in your graphs about the use that you have for nanoFramework in a very specific use case, which is low battery usage. So tell me more about your actual project, and let's see it.
Well, if we go back to the code, I mean, there is this function go to sleep, right? And here what you will tell to your MCU is basically to go to sleep. And here I just like set up the sleep timer and say sleep, and it will just go deep sleep. So what you will consume in terms of energy, it's really few micro amperes. So very, very, very limited. So even overnight, it consumes almost nothing. And then when it will wake up, it will do all the full process. It takes about like less than 10 seconds to do all of that, connecting, measuring, sending the telemetry, and that's about it. And in terms of results, I'm not a front-end developer. I like embedded stuff because there is no screen. So I just created a Power BI. It's very straightforward, very easy to do once you have that connected to Azure IoT. And this is, for example, a device for today that is measuring the temperature and humidity every 30 minutes and posting that live. If I refresh, I'm not sure I'll get a data point. It will depend when was the last one, but I get the data. I have another one which I'm using to have a more precise measurements. It's just located close to the desk, and this one is connected all the time.
It should, so that one you can tune it to send data more often. But I like, and just a little question before I let you go about the sleep function. This is a functionality of the nanoFramework itself that uses whatever the hardware provides to do the kind of deep sleeps, right?
Yes, absolutely. So all hardware, all MCUs offers the ability to connect to go to sleep, and nanoFramework really abstract that from your hardware. You just have to add the package regarding your hardware. So it's an ESP32. I add this package, and then I have all the support, all magic, all transparent. So if it's an STM32, same stuff. NXP, same stuff. Texas Instruments.
And actually that means that you take the exact same code and then you run it on a different device if you have the same sensor, right? Obviously, because you use a specific library for that sensor. But you should be able to transpose your code from one board to another one seamlessly because it's abstracted or the implementations are abstracted by the nanoFramework, right?
Exactly, and that's the beauty. So here there is nothing that telling you how you have to go, and connect to this specific pin. It's using I2C. You just understand where the I2C pins are on the other board. You connect, and you are good to go. I've put it in the comments for convenience, which are the pins used, so that if you have an SP32, you can do it. But here you will have to change the package, the hardware package, rebuild for the other device, deploy, good to go. No, not a single line of code to change.
Beautiful, beautiful, Laurent. So this is an open source project. It's on GitHub, github.com/nanoFramework. As you were saying, you're looking for sponsors, but you're looking for contributors as well. If you want to add your own board in there, new sensors, it's open for contributions, right?
Absolutely.
Fantastic. Laurent, thanks a lot, and have a great day, night, whatever it is. We don't know anymore. And I hope to see you soon for more about the nanoFramework on the IoT Show. Have a great day.
Absolutely. I'll
See you
be back.
soon.
Thank you so much. Bye.
Goodbye.